Assalamualaikum. My name is Nur Shazana binti Suda. ID number KA19223. And for this subject, BKF1243, Analytical Chemistry, I will present about the inductively coupled plasma mass spectrometry. Inductively coupled plasma mass spectrometry is a type of mass spectrometry which is capable of detecting metal at very low concentration. It combines a high temperature inductively coupled plasma source with a mass spectrometer. The inductively coupled plasma source converts the atom of the element in the sample to ion, and these ions are subsequently separated and detected by the mass spectrometer. And then the plasma is ionized by heating the gas with electromagnetic coil. So plasma is the one of the three states of matter. It consists of free electron, positive ion, and neutral atoms. So based on the figure, the blue flame is inductively coupled plasma. The grey one is the sample that to be analysed passed through the inductive coupled plasma, and due to the high temperature of inductive coupled plasma, the sample is ionized. Next, we move to the principle of inductively coupled plasma mass spectrometry. So firstly, a liquid sample is mixed with argon gas by the nebulizer to form an aerosol. The aerosol droplets are dried, decomposed, atomized, and finally ionized, producing a positive charge of ion. If a solid sample is used, it can be introduced by using laser ablation. The ions are extracted from the plasma into interface through the sampling orifice and then through the skimmer cone into the high vacuum reagent containing the ion lenses and mass analyzer. Electrostatic lenses focused the ion beam and separated the positive ion from the unwanted neutral species by bending them into the reaction cell. Next, the ion enter the quadruple mass filter and separated based on their mass to charge ratio. Only the target ion is stable and passes along the exit of the quadrupole. The quadrupole scan rapidly across the mass range and passes each mass of interest sequentially to the electron multiplier detector, and finally ions are measured using a discrete dynode detector that provides ninth order of linear dynamic range. Now I will explain about four major components in inductively coupled plasma mass spectrometry. First is sample introduction system, second is inductively coupled plasma torch, third is interface, and fourth is mass spectrometer. So for sample introduction system, it composed of a nebulizer and spray chamber that provide the means of getting sample into the instrument. Second is inductively coupled plasma torch, which is generate the ion plasma which serve as the ion source of the inductively coupled plasma mass spectrometry. Third is interface, which link the atmospheric pressure inductively coupled plasma ion source to the high vacuum mass spectrometer. And then lastly is mass spectrometer, which act as a mass filter to sort ion by their mass to charge ratio. One of the largest volume uses of inductively coupled plasma mass spectrometry is in medical and forensic field, specifically toxicology. So another primary use for this instrument is in environmental such application in water testing. There are some advantages and disadvantages of inductively coupled plasma mass spectrometry. So for advantages, of course, inductively coupled plasma mass spectrometry have a low detection limit, which is it going to take the low concentration, and then high sensitivity, which it has a great ability to respond to the specific constituent. Next is fast analysis time and also the large dynamic range. So for the disadvantages, inductively coupled plasma mass spectrometry is the high capital cost. Although recently introduced benchtop instruments are considerably less expensive. Inductively coupled plasma use the heavier element that suit to the analysis, since the lighter element suffer from more interference.
Thank you, Shazana. So I will proceed with my presentation. My name is Putri Nur Sabrina binti Muhammad Isri. My metric ID is KA19209. So today I will explain about the scattering spectroscopy. So for your information, scattering spectroscopy has other different names such as Raman spectroscopy and light scattering spectroscopy. Even though the names are different, but the function are still the same. So I decided to explain more about Raman spectroscopy in this slide. So we move to the first slide. Is the origin of Raman scattering. When a monochromatic radiation of frequency is passed through a non-absorbing medium, it is found that most of it is transmitted without any change and some of it is scattered. The scattering of radiation with change of frequency is called Raman scattering. When the light is scattered from a molecule, most of the photons are elastically scattered. The term is Rayleigh scattering. Next is the scattered photons have the same energy and frequency or wavelength as the incident photons. The Raman scattering can occur in three ways, which in vibrational, rotational, or electronic energy of molecule. Next slide. This is the basic principle of Raman spectroscopy. Okay, for Raman spectroscopy, a laser source is used in the Raman scattering because it is a very intense beam of nearly monochromatic light that can interact with sample molecules. Next, Rayleigh scattering will occur when incident of electromagnetic radiation in use and oscillating dipole in a molecule which re-radiated at the same frequency. For the Raman scattering, it will occur when monochromatic light is scattered by a molecule and the scattered light has been weakly modulated by the characteristic frequencies of the molecule. So we move to the next slide, which is the schematic diagram for Raman spectroscopy. In this schematic diagram, there are four major components that we have to remember. Firstly is the excitation source, which is laser. Okay, we are using laser source because the high intensity of laser is necessary to produce Raman scattering or sufficient intensity to be measured with a reasonable signal to noise ratio. Second is the sample illumination system and light collection optics. Okay, there are three samples that can be used, which are liquid samples, solid samples, and gas samples. Okay, next is the wavelength selector used in Raman spectroscopy is Raman spectrometer. The Raman spectrometer measures the intensity of electromagnetic energy wavelength by wavelength from a sample that scatters laser light of specific wavelength. Lastly is the detector. The detector used is CCD array. CCD array is used to make them suitable for get a high-grade spectroscopy by need some degree of cooling. Okay, there are some applications involved in Raman spectroscopy. First is art and archaeology, carbon materials, chemistry, geology, life sciences, pharmaceutics, and semiconductors. The next is the advantages and disadvantages of Raman spectroscopy. Okay, first advantages of Raman spectroscopy is the characteristic regions for different groups. Second, Raman correlation charts available is good for aqueous-based examples and useful for a variety of samples. For the disadvantages, there are fewer technical problems and fewer peaks, interference from fluorescence, higher cost due to the cost of laser source, and signal weak, which are 10 to the power of -8.
According to the comparison table, inductively coupled plasma mass spectrometry used to ionize the sample while scattering spectroscopy used to detect vibrational, rotational and other state in molecule. Using a scattering spectroscopy, it provides detailed information about chemical structure, phase, crystallinity and molecular interaction. Next, most of the application involved with inductively coupled plasma mass spectrometry is in environmental, food, petrochemical, forensic, and nuclear. In Raman spectroscopy, it is usually used in art and archaeology, carbon material, and also the chemistry.
So I will continue to explain about the advantages and limitation of each category. So ICP-MS suitable for gas-based example, while Raman spectroscopy is fit for aqueous-based example. ICP-MS in the gas-based such as it can be analysed directly by the plasma, but if solids and liquids have to convert to aerosol form first. So the liquid samples usually are used in Raman spectroscopy because water is weak Raman scattered. Furthermore, both of the categories have extreme and high sensitivity. ICP-MS has wide dynamic range and record a good accuracy and precision of value. Raman spectroscopy has good advantages, which are measurement quickness and measurement stability. It means that the Raman spectrometer measures the value in a short time but with a good stability. Next is for the limitation of each category. The ICP-MS has a high running cost and is not suitable for on-site and in-situ analysis. It also requires sample pre-treatment and skilled operators to undergo the process. ICP-MS is used for relatively big volume samples because it has the ability to determine the isotope composition of a sample using less cumbersome pre-treatment procedures than other mass spectrometry techniques. The fluorescent interference in Raman spectroscopy may result from the compound analyzed or from fluorescent impurities in the sample. It also has the limited period, time of the measurement and low excitation probability. Lastly, Raman spectroscopy has the expensive cost due to the cost of laser source and has a weak signal, which are 10 to the power of -8. In a conclusion, I can conclude that Raman spectroscopy is one of vibrational spectroscopy which requires good understanding of the properties of light. ICP-MS is an ideal choice for the laboratory that is seeking the lowest possible detection limits and the highest level of productivity available. The ICP-MS is another way to determine the elemental contents of samples.
It is also accomplished this by counting the number of ions at certain mass of the element instead of the light emitted by the element as in optical technique. Inductively coupled plasma mass spectrometry has many advantages over the other technologies. The technique is relatively free from interference, but if the interference do exist, it can be reduced or removed through the use of a universal cell operating in either the collision mode or the reaction mode.
That's all from us. Thank you. Bye.